Hello and welcome to the video explanation of our engineering expedition course project of a gaming machine. This is Team 9 of P Division and the name of our gaming machine is Laserlight. Our team consists of 4 members, namely Sahana, Sachin, Mansi and myself, Ankit. This project would not have been possible without the constant guidance and support of Professor Sanjeev Kawale. Based on the need statement given to our team, the members of our team framed all possible questions and answers that would help us in understanding the requirements of the client for our machine. Simultaneously, we categorize the various objectives, constraints, and functions for our model. Finally, the problem definition we came forward is displayed here. Based on the various functions listed according to the requirements of the client, we constructed a function tree listing all the functions to be performed by Laserlight. The function tree is under 4 specific subheadings, namely controlling targets, controlling gun, interactions, and casing. All these functions are further clustered to form 4 different subsystems, which are target handling unit, gun handling unit, interface unit, and casing. The various functions of the target handling unit are to sense shots, time entry and exit, stop when shot, and start again after 3 seconds. The various functions enlisted under the gun handling unit are that it should be manually controllable and it should emit 1 shot at a time, whereas the only function of the interface unit is to alert the player when scored. So these are the total subsystems identified. After spending some time brainstorming ideas, our team came up with 4 different designs for the machine. These 4 conceptual designs are not at all similar to one another in any way. Here is conceptual design 1. This is conceptual design 2. This is conceptual design 3. And this is conceptual design 4. After going through various pros and cons of the designs, we selected concept number 2 to go with the final prototype. Now let's move towards the virtual implementation process. This is the 3D model of our system. This is what our model's prototype will look after completion. Now let us have a look at the 3D model of our system. This is the 3D model of our system. Let me give you a 360-degree look at the system. As you can see, this is the casing of our system. We've decided to keep the model without a top so that the players can see the various mechanisms that are being played inside the machine. Now let me remove the visibility of the casing so that we can see the inner components of the machine. As you can see, the casing was supported using various types of aluminum putties. Inside the model, there are 10 targets attached to various mechanisms. In total, we have 3 mechanisms. Now let's look at the first mechanism. The first mechanism is cannon follower mechanism. This mechanism uses a DC motor. This is used to give the target different heights, which depends on the shape of the cam. Now moving on to the second mechanism, that is the rack and pinion mechanism. This mechanism enables the target for a sideways motion. It also uses DC motor to power itself. Now moving on to the third mechanism, that is the servo mechanism. This mechanism uses a servo motor to power itself. This mechanism gives a rotational motion to 2 different targets attached to the same arm on different sides. This enables a circular motion for the targets. In total, there are 5 rows in which the targets are attached. The first row contains 2 cannon follower mechanisms, the second row contains a sideways mechanism, the third row contains a servo mechanism, the fourth row again a sideways mechanism, and the fifth row again a servo mechanism. The scores depends on the various different rows. Depending on the distance, the score gets added up. The first row has 10 points, the second row another 10 points, that is 20 points. Third row 30 points, fourth row 40 points, and fifth row 50 points. So this was the 3D model of our team. This is the circuit diagram representation of our model. We already know that there are in total 3 mechanisms in our model. These 3 mechanisms' circuit representations are shown in the right hand side. As we can see here, we have used 4 DC motors of 60 RPM and 2 servo motors MG995. There is also a motor driver connected to control the speed of the motors. In total, there are 10 LDRs and 10 LEDs connected in the system, one for each target. Now let's move towards the Simulink model of our course project. This is the Simulink model which is controlling the whole gameplay of the Laser Knight. The game maintains a playtime of 3 minutes for each player, within which the player has to score as much as possible. Moving on to the bill of materials required for our entire model. This table contains all the details of the components used in our course project. Now let's take a look at motor sizing of the system. We require two types of motors of our system: DC motors and servo motors. After the calculations considering all parameters, we found out that our system needs DC motors of 60 RPM and servo motor MG995 with a torque of 10 kg/cm at 4.8 volts. Now displayed is the functional specifications table for the system. This table specifies the functions that a system or component must perform. We have identified in total 11 functions and specified them in detail. Now let's move on to the simulation of the Simulink model.
So this is the simulation model for our system. This simulation model consists of 6 charts. We'll start from the beginning. This is the toggle switch for maintaining the gameplay of the system. This will give input to this chart for which is used for maintaining time. The total gameplay for any player is 3 minutes. These are the push buttons to give inputs in place of LDRs. These LDRs will give inputs to these charts named LED control, and these are the LED displays which will show whether the LED is switched on and off. And this is the buzzer display. Whenever an LDR is short, the buzzer will beep for 2 seconds. Next up, this is the chart for maintaining the score of the player. This display displays the score of the player, and this gauge also shows the score. This gauge is connected to this display named score. Next up, we have a chart for our mechanism one, that is cam and follower. It gives 3 outputs, namely motor 1 direction, motor 2 direction, and motor speed 1. Next up, we have rack and pinion, that is mechanism 2, and this gives 4 outputs. The fourth output is just a temporary output variable for maintaining the multi-state image beside. The last chart is for servo mechanism. It gives output to the servo motor in form of angles. We'll begin with the time chart. Total time maintained for the gameplay is 180 seconds, that is 3 minutes. Next up, we have the chart for LED control. Whenever any LDR is short, the LED switches off for 3 seconds and again gets switched on. All the LTRs are maintained in parallel decomposition, and here there's the buzzer chart. Whenever any of the LDRs is short, the buzzer will beep for 2 seconds. Next up, we have the scoring chart. In our game, the LDRs are maintained in 5 different separate rows. Each row has separate scores. Whenever any LDR of the specific row is short, the score gets added up. This is the chart for cam and follow mechanism 1. This gives output to the motor 1, motor 2, and the speed. Next up, we have rack and pinion, that is mechanism 2. This also gives direction for motor 3, motor 4, as well as the speed for the motors. It also gives a temporary output variable X to maintain the multi-state image beside. The last chart is the servo mechanism chart. This gives output for the servo motor angles. Let us simulate this model and see what happens. You can see the multi-state image has changed here. Now I'll switch on the machine. You can see that the time has started going on and it is maintaining a time of 3 minutes. Here we'll change the value for give an input for LDR1, and we can see that the score has added up and it has become 10 now. Now we'll see for LDR3, we should notice the LED3 display over here as well as the score display here. We can see that the LED3 display was 0 for 3 seconds. We can again do this and see that the LED3 display is 0 for 3 seconds and the score is also added up 22 times. So now the score is 50. The score is perfectly displayed in the gauge beside. Now I'll put a constant for 0 for LDR1, and now we can see that the LED will switch off for 3 seconds and the buzzer will also beep every 2 seconds. We can see the flow of the chart over here. So now I'll change the constant value over here so the score stops getting added. Now the total score is 120. Moving next, we have the cabin follower chart. We can see the flow of states and the score values getting displayed here. Next up, we have the rack and pinion mechanism 2, and we can see that the value is getting changed over here, and you can see the flow of states too. This multi-state image is showing game on right now. Next up, we have this servo mechanism chart. We can see that the angle for the servo keeps getting changed. This angle will be in between 10 to 170 degrees. You can see the servo angle in this display. Now I'll switch off the machine. We can see that the multi-state image is now displaying game over. And the gauge is showing the final score of the player. This was the simulation for our model. So this was all from our team. We're thankful for such a wonderful learning experience.